Okay, very well. Good morning. I just wanted to show you how this model that I prepared works. So over here, I just try to talk about the capacity of electricity generation in Georgia. So the items that are included is the annual increase in the demand that we have. We have a capacity construction that happens every year. We have a decommissioning of some of those power plants. And then we have a total capacity of electricity that Georgia has in gigawatt. Then I divided that between renewable, low emission, and high emission over here. So for each of them, we will have a different rate of construction. And then those rate of construction is dependent based on the policy that we have. Are we going to assign more of the demand and generate and create more renewable power plant, or maybe gas power plant, or going to coal? And we will have an outflow of the total capacity. I call it decommissioning. It might be policy related that we just want to reduce that annually. So as an example, for coal power plant, I assume 3% of the capacity will go out of grid every year. And then we have a lifetime retirement based on the year that they have a useful life. They will go with some ratio out of the capacity. With this very simple, and also this decommissioning were added all out together over here, which means that we will decide what type of capacity we will create, and based on the lifetime and policy, we decommission that. The entire goal of it is to see between 1990 and 2060, the years that I decided for this design, based on different increase in the demand and different decisions on construction of the capacity. How is it going to change? So I ran that for few models. So the way that it works, we just go to the run model, try to change this. As an example, if we decide to keep more coal into the grid, instead of 3% annually, if we go and change it to 1%, you will see the result of it here, that the rate of decommissioning reduced significantly. So I want to go back again to 3% annually. And we will see that the coal went up to 7 gigawatts in 2020, and then gradually retired all of them in the grid to close to zero in future years. In the other, at the same time, you can see over here the, let's say, gas power plant, that based on the two scenarios that I modeled over here, one of them, the green one, needs a higher capacity over here in case that the demand went up to recover for the coal, and the electricity went up to recover. Also the renewable one increased significantly. So that's the kind of dynamics that I see for electricity generation. In the next video, I will describe how I can expand it to the other factors and other area of drawdown project.